Hi, okay, welcome to this revision video for the calculator paper. It is a selection of questions that I've handwritten myself, and I have tried to make them challenging. I've done that because I really want you out of your comfort zone, thinking about what you need to do when you are faced with things that you're not sure about, and just give you some ideas on how to approach questions when they are quite hard. It's all about thinking, what am I looking at? What do I know? Now, it starts at grade 6. So if you want to be practicing the crossover questions, then you are going to want to look at the foundation. The foundation video that I've made is 3 to 5. And there's a lot of challenge in the crossover questions themselves. So it's well worth a visit. This is starting at grade 6. I put, a couple in to just sort of ease us in a little bit. And then it does really take off. So I hope it's useful. I hope you enjoy it. As always, the questions are available to download in the description. So let's get on with it. Okay, so our first question is a trusty triple bracket. So to get our first mark, we're going to ignore the third bracket and just do our method for multiplying out 2 brackets. I use crab's claw, so that's what I'm going to do here. Okay, so you just need to be very mindful here. You remember that negative and get this bit right. That's really common to go wrong. Going to collect up the middle. And we've got 2x squared plus x minus 15. Now, you can just bracket this and pop your third one and repeat the whole process. But obviously, you won't just be going to 2 terms, you'll be going to a third one as well. It works perfectly fine. But for me, I quite like moving from that method into the grid method because it just makes it easier to see what's going on. So the grid method just means that you're popping it into a grid, x minus 2, and then you're multiplying in like a times table grid. And again, watch those negatives. We've got negative 2 times negative 15 to give us positive 30. I also refer to this as my nugget method because I'm going to be grouping those that go together. This term is the only term that I've got that's cubic. These are both to the power 2. These are single x's, and that is a number on its own. So I'm grouping, putting them into little nuggets. So my final answer is 2x cubed. I'm at 1x, I'm taking away 4. So I've got minus 3x squared, minus 15x, minus 2. A further 2 places down, minus 17x plus 30. And that would be my final answer. Okay, so we've got a bounds question. First thing we want to do is find the upper and lower bounds for the 2 numbers that we've been given. There's different ways to think and see this. I personally like the number line method where you put the number that you've been given and then you continue the number line either side of that number. So if it's 2 decimal places, it's a 2 decimal place number line. Now you've got 14.27 and 14.25, and our bounds are slap bang in the middle. So my lower bound is going to equal 14.255, and my upper bound is going to equal 14.265. And then I'm going to repeat the process with significant figures. People get a little bit confused with the significant figure one, especially when they're whole numbers. Just try and see the number for what it is and then repeat it. So rather than thinking significant figures here, I am thinking, oh, it's 1 decimal place. So it's a 1 decimal place number line. I could have had a number that was rounded to 1 significant. Let's say it was that. I would see that as tens. So my next one would be 80, 1 significant figure, and so on. So try not to let significant figures, if it appears, put you off too much. Now, what we've got in our formula that we've been given is a division. They want us to find the upper bound. To get the upper bound with a division, you need to take the biggest possible value and divide that by the smallest possible, because you'll fit more of the smaller into the bigger. So what we're going to be taking is the largest for A and the smallest for B. Now, if you don't know that or you can't see that, my best top tip that I can possibly give when it comes to bounds is just do them all. You're on a calculator paper, it's really not going to take that long. And if you do them all, you'll be able to see from the result which one gives you the greatest value and therefore is the correct answer. So you've got nothing to lose. There's no sense guessing what would be the right combination. If you're not sure, do them all, okay? Now, it's being raised to the power half. We've got a calculator, so we can just throw that whole thing in. We've got to do it to 3 significant figures. So our final answer would be 1.51. Now, I will mention very quickly a different type of bounds question where you're not being asked to find a specific bound like I've done here. It may say, by using bounds, work out a suitable answer. If you get a question like that where they're not referencing work out the upper, work out the lower, then you are working them all out. There is no option there. And your answer is the one where they all round to the same thing. So I hope without the visual, that makes sense. Okay, so we've got a transformation of graph question. They've given us a graph and then they want us to draw a transformed version of it. This is away from the x. It could have been in with the x. So that's what I mean by in, but it's not in, it is out. When it is out, it affects the y coordinate. So that's something that we really want to know and understand. And the same thing is happening here. This negative, it will cause a flipping action, but what coordinate does it affect? Is it going to flip in the x? Is it going to flip in the y? If it's away from the x, which it is, if it was with the x, it would be like this, but away from the x means it affects the y coordinate. So let's take a point. Let's take this one here. That coordinate is -5, 3. I am now going to flip the y coordinate to give me -5, -3. I'm also going to add 2, which is going to give me -5, -1. And that is the point of my first coordinate. I would repeat this on all the key points. So I would flip and add 2 on the y coordinate for each one of those points so that I can then transform the graph. And that's what your graph would look like when it was finished. Now, another way to do this, especially with your tracing paper, would be to trace it, and then flip it in the x-axis, and then you can slide it up 2 places for that add to movement, and then that would show you where to put it as well. But I think it's really useful to know how it all works on the coordinates, because you could get a question that is just wordy rather than a graph, which is what we've got with part B. So if we think about this question, we've gone in with the x and out from the x. Now, when you are in with the x on a translation like this, the opposite will actually happen. You will take away 2 from the x coordinate. So we've been given 5 - 1, and we will be taking away 2 from the x coordinate. The -5 is away from the x, and you do exactly what you see. There's no change of sign here. So we will take away 5 from the y coordinate, and that will create us 3 - 6 as the transformed point. Okay, so we're being asked to solve this equation. Now, this equation it's quite unusual, isn't it? It's actually a rearranged quadratic. So how do you know that? It's not easy to see that this is a quadratic. The giveaway is the root. It's quite unusual to see a square root. And if we were to get rid of that, we would need to raise it to the power 2 to cancel it out. And when that works on all the other terms, you will start to see that quadratic appear. Now, I'm not actually going to do it like that. I'm going to start by rearranging and getting it to equal 0 because a quadratic is going to need to equal 0 before I can solve it anyway. Now that I've got it all on the left-hand side, I am going to raise every term to the power 2. Now, I need to be careful and remember everything in that term needs to be raised to the power of 2. So that would give me 4x squared. This will literally just cancel out that square root. And then 1 to the power of 2 is 1. I'm going to use the quadratic formula, which is available on the formula sheet. So my A is equal to 4, B is equal to 7, C is equal to 1, and then we can populate. Tidy it up. And then you would split your plus and your minus so that you then start to see those two solutions. Check how they want the solution. It's to 2 decimal places. So we've got minus 0.16 and minus 1.59. And there we go. So a little bit of a different way to ask you to be using the quadratic formula there. Okay, we've got a kite in our next question. We've been given some information and we're being told the area is 71.3 and we need to work out the perimeter. So the first thing I'm going to do is pop 11.5 on this edge because these are equal and actually these two are equal. So it's good to have that where I can see it and don't forget about it. Now they're telling me the area. So I need to just stop and think, okay, how is that going to actually help me? What's the formula for the area of a kite? And there isn't one. So I can't use a given formula. There'll be nothing on the formula sheet to help. So I've got to think about how I'm going to break the problem up. Now, what I'm going to do is pop a line across and create 2 triangles because I do know the formula for the area of the triangles. If I look at this first one, I've got my 2 edges and an angle. So this is the sine formula for the area of a triangle, which is on your formula sheet. So I'll substitute in the information and work that out. And then we're going to work out the area of the smaller triangle by taking away the answer that we have just created on our calculator. So what I'm going to do throughout this example is I'm going to use my answer key. I'm going to show you how I'm using it and when I'm using it. There is no point in retyping it. I want to keep things as accurate as I can throughout. So I'm going to hit the answer key so the entire number is used, and that is going to give me 16.4798, and on it goes. And again, that is the area of the smaller triangle. What I don't have are any edges on this smaller triangle. Now, I could use the cosine rule and I could find that edge, and that would work absolutely beautifully. It would. I could split through the middle and create some right-angled triangles, and I could use my basic trig, my SOHCAHTOA. Either way will work to get you the result. I'm going to go with the SOHCAHTOA so that anybody that's a little less confident with the advanced trig can see how in this particular question you can get around and not use it. So I'm just going to transport out one of the triangles. I know that's 11.5. I know that my angle is 28. And I actually want to find this here, which is opposite and hypotenuse. So I would end up with sine 28. That's the side I want, over 11.5. So my x would equal, don't forget to close that bracket. Now, I'm only finding that section there. I want the base of this triangle. So as I say, cosine rule would have got you straight there. I'm just going to double this. So I'm literally pressing times 2, and I'm getting 10.7978. I know the area of this triangle. I worked that out first. I now know its base. I know base times height divided by 2 will help me find the height. So that is what I'm going to do next. Now the base is 10.7978. Times that by the height, divide it by 2, and that is going to equal 16.4798. So I've set it up. Now, what's going to happen is my divide by 2 will come across, and it will land as times 2. And then I would divide through by my answer. And when I put that into my calculator, I get 3.0524, and on it goes. So I've now found this part. I want the edge of this kite here. And I am now in a position to use Pythag to help me finish that off. So I'm going to just sketch it out so I'm really clear about all my numbers and what I'm doing. 3.05 and on it goes is on that edge. My 5.3989 is on that edge. And obviously, as I've said, I'm going to use Pythag to get that side. So 3.05 and on it goes is already on my calculator. So all I have to do really is just hit the square button. I'm then going to add 5.3989. Now notice I'm using, when I have to use a rounded version, I'm using 4 decimal places. It will really help me keep my accuracy. That is going to give me 38.4654. And then I'm going to square root the answer, and I'm going to get 6.202, and on it goes. So I now know that my long edges are 11.5 plus 11.5. I've also got to add in 2 lots of my last answer. And I pop all that in to get a final answer of 35.404. On it goes. Correct to 3 significant figures, it would be 35.4 centimeters. I'll highlight that because I tried to squeeze it all on the same screen, but obviously there was a lot of working out. I will go back to reiterating the cosine rule could find you the base of that triangle. It's a real personal thing almost. It's a bit like when you look out the window, one person's going to spot, I don't know, the tree on the right, and another person might spot the church on the left. You know, what you see and how you interpret will be different to the next person. If you hit a brick wall with your first idea, then you try another idea. And that's just the way problem solving works in maths. So I hope I have explained that in a way that's really useful. Okay, we've got a box plot question. Now, box plots, at the stage of this video being made, box plot and cumulative frequencies were still outstanding. This is just really focusing on the box plots. First thing they've asked us to do is draw a box plot to display the results in the table. So you have to be very, very careful and check that you've read through all this information. We've got the lowest and the highest score. We've got the lower quartile. We've got the median, but we don't have the upper. We have the interquartile range. But because this value here is greater than the rest of the values, it feels like it could be the upper, and it would be very easy to just use 42. What we have to do is calculate the upper quartile. So the upper quartile, take the lower quartile, gives us the interquartile range. So all we have to do is add on that 23 to get our upper quartile of 65. Now we can plot all those significant points. Okay, once plotted, it should look like this. Now, I created the question, so it's me you blame for a terrible scale, and I do apologise. Plotting that did not go brilliantly because we've obviously don't have it sectioned into 5, we have it sectioned into 4. And I didn't spot that until I started making the video, if I'm honest with you. So apologies for making that a tricky one to plot. But if it's taken that shape and you've done your very best, then all is well. Okay, so we are then given the results for the girls and asked to make some comparisons. Now, this is really important. You could be comparing two box plots. You could be comparing a box plot with a cumulative frequency. You could be comparing it to just a list of numbers. If you are making a comparison, they want you to comment on 2 areas. They want you to comment on the median and the interquartile range. Even if it's in a list of numbers, you will have to go away and find that information from the list so that you can talk about those 2 things. So in sentences, you might write something along the lines of the median for the boys is lower than the girls, or the girls is higher than the boys. The interquartile range for the boys is bigger, making their results more varied. They are more spread out, so they are more varied than the girls. So just a comment about the median and the interquartile range is what they are looking for there. Okay, algebraic fractions, super, super common. We can't tell whether it's going to be in paper 2 or paper 3, but we can be fairly confident you will be tested here. This looks way more complicated than it is. So what's really important is that you break the problem down. And if you are somebody that isn't confident at all with this type of thing, then really try and zoom in on just one element and think, well, I know what I could do with that. Don't know if it's right or not, but I'll do it anyway. And take that attitude when you are facing something that you're not sure. If there's something within it that you think, well, I don't know if this is the right thing, but I know this, just do it anyway, okay? So if we look at our fraction inside the bracket, they have quadratics on them. And the first thing that we want to do is simplify, and they are using that word. We want to simplify this fraction. To do that, we have to factorize both quadratics. Now, the top quadratic is the difference of 2 squares. So the square root of my 36 is 6. So it's plus 6 and minus 6. So that's done quite nicely. For the 3x squared, you will have your own methods. Obviously, I'm going to do the method that I have taught my students. I will also put a link in so that you are able to go away and see it in a bit more detail, because I'm just going to talk through it without too much detail. So we are going to open our brackets, drop in the 3x, do our signs. It starts negative, so they are both going to be negative. We then multiply the first and the last term to get 36, and we look at the factors of 36. 18 and 2 are the ones that I want because I want to make 20. Because my signs are both negative, I don't have to overthink that. I can just throw them in. And now I will simplify my brackets where I can. This bracket, both terms are in the 3 times table, so I can divide through. That's going to give me x minus 6. And this bracket is already in its simplified version, which is 3x minus 2. Now I've got them both factorized. I can set them up on top of each other. So I'm just going to use this one and bring the other one across. And I am going to write them the other way around, just so that I can get that x minus 6 really clear on top of each other. They cancel out. Now I am left with 4 take x plus 6 over 3x minus 2. Now, this is still a fraction, so I have to use my rules for subtracting fractions, which means the denominators need to be the same. So my 4 is going to get multiplied by 3x minus 2. So if we put it over 1, then both the top and the bottom will get multiplied through. That leads to me getting the following. 4 times 3x minus 2 minus 6 plus x. And then both of these fractions are over 3x minus 2. So you can just see how that's multiplied top and bottom. I'm going to concentrate solely on my numerator because my denominator is now the same. So I'm going to expand. And now I need to be really careful. This negative is acting on all of this. So I end up with minus 6, but this minus and positive will create a minus. So I have negative 6. That tidies to 11x minus 14 all over 3x minus 2. And then I can just double check the form that they were telling me. I should have a number in front of the x, a number in front of the x, and then a negative. And I've got all of those elements. They are all integers. It's feeling good. Okay, so I think this is possibly the hardest. I guess it just depends on your knowledge and how confident you feel about the topics that you've seen so far. We have a story, and the first thing we need to do is model that story. We're being told that a ship travels from port A on a bearing of 035 for 10.5 kilometers. So I'm going to put my north line in, and that is my port A. I'm going to just roughly do an angle that's small, that could represent 035. And I'm going to put on the fact that we've traveled 10.5 kilometers. And then he travels directly south. He travels for 13.5 kilometers. How far and on what bearing must the ship travel to return to its original starting point? So we're at B currently. So what we're trying to work out is that distance and that bearing. So that's my diagram of the story and my understanding of what it is I'm trying to achieve. I'm now going to redraw the triangle that I've created without quite so much busyness so that I can hopefully see a starting point. Now, ideally, I need an angle. I need an angle in my triangle. The only angle I've got in my diagram is outside of the triangle. Okay. However, if I use my north lines as parallel lines, which is what they are, then I do have an angle inside because I've got alternate angles making that 35. So I'm going to transfer that information across. That is 35 degrees. I am now in a really nice place. I have what I call my sandwich. So my angle sandwich between two given sides. And when I have my sandwich, I have my cosine rule. So I will be able to use the cosine rule to find the length, to find the distance. So I've got the rule copied down from the formula sheet. I'm now going to substitute all of the numbers in. I am always very nervous about putting everything into the calculator in one go. So I generally do the first section and get that result. And then I do my second section. And obviously I can use my answer key when I take those away so I don't have to mess up with any rounding. I end up with 60.27. Obviously that is a squared. So I need to square root, and then I get that side of 7.763. Now we've got to give both our answers correct to one decimal place. So our distance is 7.8 kilometers, and I have done that section of the question. My next task is to work out this bearing. Now what I'm going to do is I'm going to work out this angle and then take it from 360 so that I have the angle I actually want. So I'm going to mark it on my diagram. This is the angle I want to find. I have got enough information to be able to use the sine rule. So I've got my 35, and opposite my 35 is the value I've just found. Now I don't want to use a rounded version, so I revert back to the original, and my x that I want to find is opposite 10.5. So we're going to get this set up. Now remember, you can have the sine rule with the sine as the denominator or the numerator. You can just flip your fractions over, and that's what we're going to do because our x will be attached to the sign, and we want that as a numerator, not a denominator. Equaling sine x over 10.5. Now we're going to rearrange that. So this will come across and it's going to land as times 10.5. And when we do that, we get 0.7758 equaling our sine x. Sine needs to come across. It will land as its opposite, which is sine -1. We will put in our answer on our calculator key, and that will give us 50.877, on and on it goes. And then just to finish it off, remember, we have to take it away from 360. One decimal place gives us our final answer. Okay, our last question. We have a straight line, L1, which is perpendicular to another straight line that passes through two particular points. Now, what I know is that if I've got a line and the other is perpendicular, creates that right angle, then that perpendicular gradient is the opposite reciprocal. And I'll show you what I mean. So we're going to use the first two coordinates to work out the gradient of the line. So y2 take away y1 over x2 take away x1. That's your formula. The way that I look at it is I just go, that one take away that one take away that one, and I just set it up. That gives me 4 over 6, which cancels down to 2 over 3. Now that's the gradient of the line that our L1 passes through. So we want the perpendicular gradient, which is opposite sign, reciprocal. Now we can take the coordinate that they've given us and put it into our equation. Now, we have learned that y minus y1 equals mx minus x1. We need a gradient, which we have got. We need coordinates, which we have. So we just substitute in. We end up with y minus 9 equaling minus 3 over 2 x minus 0. This tidies up to y equals minus 3 over 2. And then that negative 9 has come across and landed as positive 9. We have to, I lost my x. See, there it is. We have to work out the value of x when y is 3. So Don't lose sight of the fact that your coordinates are X and Y, and they are your X and Y values in your Y equals mx plus c. So we're being told that we've got to find X when Y is 3. So we just substitute 3 where the Y is. And then we rearrange to get X on its own. And our final answer is X equals 4. Okay, I hope you have found this useful. I have tried to write things that are a little different in the way that they appear, and they're making you think more about how you problem solve with your knowledge rather than you just apply your knowledge. I will be writing paper 3 as soon as I've seen paper 2, and then I will get it out as fast as I can. I am not pre-writing it. It will be based on the most popular topics that we haven't seen yet. And yeah, it should be very valuable because we'll have had so much content gone by then that we should be able to get a really good best guess paper pulled together for you. All right, well, good luck with the rest of your revision. If I get a chance to do a little bit more, I will. If not, keep your eye open for that paper 3. And don't forget, there is a wealth of content on the channel, absolutely loads available to you. So do go and check out those playlists.